Hi guys, I hope you're all doing well. I am going to help you with the calculations for lab report 6 so you can determine if the unknown is carbon dioxide or methane. There was an email that was sent out on Wednesday because there was an error in the sample data. So go back and see what has changed because there is a new room air pressure and a new mass for trial 2. So when you do the calculations for trial 2, it is accurate. So for this problem, there are two equations. There is the density of air and the ideal gas law. So for the density of air, this first one, we're going to use it to find the mass of air so we can find the mass of the ice gas. Once you find the mass of the ice gas, you can plug it into the ideal gas law equation to find the molar mass. Although you are not going to use this equation because you do not know what substance you have, so you cannot find the moles. So instead, you're going to use this equation. It will be a lot easier. So this little m right here, you're going to plug in the mass of the ice gas when you calculate it. And then this right here is the molar mass. So first we're going to calculate the density of air. So density of air, 0.3535, pressure over temperature. So the pressure should be in atmospheres, and I already converted it for you. And you're going to look at the room air pressure. Temperature is in Kelvin, and that is in trial 1. So plug everything in. 1.0103 atmospheres per 292.9 Kelvin. When you do that, the density of air is 0.001217 grams per milliliter. So the atmospheres per Kelvin turns into grams per milliliter. So after you do that, you have to find the mass of the air so you can subtract it from the flask. So you're going to use the density equation, which is mass over volume, and you're going to solve for mass, so volume goes there. So mass equals volume times density. And this will get you the mass of the air. So volume is 282.3 milliliters times the density that you just calculated, which is 0.001217 grams per milliliter. Milliliters cancel out, and you're left with just grams. And the answer you get should be 0.34437 grams. That is the mass of the air. Now you're just going to focus on these values up here. So you're going to take the mass of the flask with air, subtracted from the mass of the air, so you get the mass of an empty flask. Okay? and then plug in those values. So 130.452 grams minus 0.3437 grams, and that should get you 130.10746 grams. And that is the mass of the empty flask. Now you want the mass of the ice gas. So you are going to subtract, you're going to subtract mass of flask with ice gas minus the empty flask to get just the mass of the ice gas. So that's 130.621 grams minus 130.10746 grams. When you do that, the answer you should get is 0.513337 grams. Okay. Now, that is your M for this equation up here. That is your M. So now just plug it in. So molar mass equals the mass of the ice gas, RT over PV. So 0.51337 grams. R is 0.08206. And then the temperature is up here. It's 292.9. Divide that by the pressure, which is the room air pressure in atmospheres. You can just say it's 1 atm. And then the volume is up here, but you want it in liters. So just move the decimal over 3 times. So now that cancels out, liters cancels out, and Kelvin cancels out. So now the calculated molar mass of the unknown substance that we got is 43.70 grams per mole. And that is correct because grams per mole is for molar mass. Now you're going to compare it to the molar mass of carbon dioxide and methane. And the molar mass of CO2 is 44 grams per mole, and the molar mass of methane is 16 grams per mole. So now compare, see which one's closer. Whichever it's closest to is your unknown. So this is the calculation for trial 1. Hopefully this helps. If you have any questions, you can always email me. So yeah, hopefully this helps.